Assalamu alaikum. Good evening. Greetings, everyone. You're listening to Zoya Khan from Expert Trainers Academy. If you're new here, let me introduce you about us. Expert Trainers Academy is world-renowned provider of safety training and ISO certifications, and its services are available all around the globe. We are authorized to offer courses for organizations such as OTH in United Kingdom, the European Safety Council, AOSH United Kingdom, Bharat Sevak Samaj, and India's Education Board of Vocational Training. We, Expert Trainers Academy, are committed in delivering the highest standard of health, safety, quality, and environmental training to develop a safer working environment.
So now let us start with the topic, which is for today, machine guarding. The first topic, machine guarding. Which control measure does it falls under? You can write your answers in the chat box. What are the reasons or what are the causes of machine accidents? Reaching in to clear any equipment or jams, not using lockout or tagout procedures, unauthorized person carrying out maintenance or using the machine. There may be guard is missing or loose machine guards. So these are the reasons for machine accidents. There are mechanical hazard and non-mechanical hazard. Some of the examples of mechanical hazard including crushing, shearing, entanglement, high pressure fluid injection. So these are the examples of mechanical hazard. Non-mechanical hazard, the noise that comes out from the machine, vibration that comes out of the machine, the radiation effects that comes out from the machine. These are the two things that you need to know if you're dealing with machinery hazards. If you're dealing with machines. Moving on to the next slide. Just wanted to quickly check. Either am I audible?
Yes, sir, you're audible.
All right, because something popped up, my internet is unstable. Where the mechanical hazards occur, where generally the mechanical hazard, which I said the crushing, shearing, and then puncture, and then usually it happens at the point of operation or any part of the machine which moves, such as flywheels, pulley belts, couplings, chains, gears, etc. Or where there is a feeding mechanisms and auxiliary parts of or the other components of the machine. And in running knee points where the machine meets with the belt, the running machines or rotatory part of the machine meeting with the belt. In running knee points, we will see some slides onto it in running knee points examples. The point of operation, the point where the work is performed by the employee, such as he's doing some cutting, shaping, boring, drilling, etc. Rotating parts. There might be a chances for entanglement if you're wearing a loose clothing. Avoid loose clothing when you're operating any machinery. In running knee points, see there is this belt, this rotating part of the machinery. This is in running knee points. This is again in running knee point. This is again nip point. This is again nip point. This is again nip point. So these are the various nip points of machine operation. Okay, moving on to the next slide. What are the requirements, general requirements for safeguard? It must prevent the contact of the worker to the rotating part of the machinery. And it must be secure. It must be firmly secured to the machine and it must not be easily removed. And it requires the tool for removal of any guarding systems. And it must protect from falling objects. It must not create any new hazard. It must not create interference with the protection activities of the machine. And it must allow some gap to do a lubrication for the machine to avoid friction. So these are the general requirements for the safeguards. See, there are 4 types of guard generally. How to remember this? Fiat, that's an int. Fiat, what is Fiat? Fixed guard, interlock guard, adjustable guard, and a trip device. Fixed guard, interlock guard, adjustable or self-adjustable guard, and then trip device. Guard, fix, interlock guard, adjustable and self-adjusting. Devices, sensors, pull back, restraint devices, two hand control devices, and then gates. The location and distance from the machine operation is very important. And then feeding and ejection methods, automatic or semi-automatic feeding and ejection, and then robots. And you can also use miscellaneous aids with the machine, such as barriers, protective shields, and feeding tools, etc. So these are the things we're going to see in the further slides. Moving on to the next slide. A fixed guard, it's a permanent part of machine, and it requires a tool for removal, like spanner or screwdriver, etc. It provides a barrier between the employee and the machine operation. It's a permanent part of machine, and it gives the complete protection of an employee or a machine operator to keep themselves out of the operation area. Next slide. Interlock guard. When this guard is open, the machine will not operate, or it disengages from the power. When this type of guard is open or removed, the tripping mechanism under power automatically shut off or disengages. Until and unless the guard is in place, you cannot be able to operate the machine. The example is like microwave oven that we use commonly. Moving on to the next slide. Adjustable guard. Yep. There is two types, adjustable and self-adjustable. Adjustable, the machine itself will automatically adjust its guarding system, whereas self-adjustable is a person is adjusting by himself. It provides a barrier which may be adjusted to facilitate a variety of protection operations. Wood cutting machine. It provides a barrier which moves according to the size of the dog entering into the danger area. Pullback device. You see a person who is tied up with the pullback device on his hand. It utilizes a series of cable attached to the operator hands, wrist, and or arms, primarily used on machines with stroking actions. See, allow acts to the point of operation when the slide or ram is up. See, when the slide or ram is up, it allows the operator hands to carry out some work. When the slide or ramp is down, it pulls back the hands of the operator. That's the purpose of it, this pullback device. Next slide. Hands and die feeding. Point of operation is exposed when this ram is up. Pullback device attached and properly adjusted. When the die is closed, hands withdrawn from the point of operation by pullback device. It's a safeguard for the operators and whenever they're using this pullback device during the machine operation. Moving on to the next slide. Restraint device. Again, it uses either cable or straps attached to the operator's hand and a fixed point. It must be adjusted to let the operator's hand travel within a predetermined safe area. Until that area, using that strap or cable, you would be allowed. Beyond that, the operator cannot able to go beyond that level. That's again for safeguarding the operator's hand whenever they're using the machine. Safety tripwire cables is something similar to an emergency stop button. It's a device located around the perimeter of or near the danger area. Operator must be able to reach the cable to stop the machine. It's something similar to emergency stop button. Two-hand control. How this system works, two-hand control. Both the operator hands, both the hands of the operator must be on the control. Only then the machine can be able to operate it. Even if you release one hand, the machine will come to stop. It protects the hands of the operator. That's a principle of two-hand control. Moving on to the next slide. Safeguarding by location or distance. Locate the machine or its dangerous moving parts of the machine so that they are not accessible or do not present a hazard to a worker during normal operation. So you must use a guard to maintain a safe distance from the danger area, from the operation of the machine, basically. Robots. There's a new type of engineering that has come up in the market. It's called robot engineering, which is, you might have also heard about this artificial intelligence. That is also another new program that has come up in the market today. So these two things are, and also data science. These are the three things which I'm keep hearing from the different medias: artificial intelligence, robotics, robotic engineering, and also data science. These are the three famous courses that is coming up in the market. which has more value also, and also safety as being a part of it too. The robots, machine that load and unload the stock, assembles the parts, transfer the objects, or perform different tasks. See, when we configure it, it's same like laptop. So it's everything is configured. So it's that robots work according to the configuration or the signal that has been provided. It is best used in high production process requiring repeated routine activities where they prevent other hazards to the employees. Holding tools used to place and remove stocks from the danger area. Not to be used instead of other machine safeguards, but it can be used as a supplement, like to remove some jams in the machine. So you can use this certain tools, handle tools, to remove some jams from the machineries. Some examples of Osha machine guarding requirements. When the periphery of the blades of a fan is less than 7 feet above the floor or working level, then the blade must be guarded with a guard having opening no larger than half an inch. Guarding the fan blades. Abrasive wheel machinery. The distance between the wheel periphery and the adjustable tongue must never exceed quarter inch, because when it exits more than quarter inch, you might be pulled inside when you're operating that machinery. Or if you're wearing loose clothing, then you would be entangled. Moving on to the next slide. Power transmission apparatus. Power transmission apparatus such as shafting, flywheels, pulleys, bells, it must be guarded. Less than 7 feet from the floor or working platform must be guarded. See, look at this picture on this slide. It's an unguarded belt and pulley, which is just nearby to the operator, which is not safe, and it must be guarded. So, machine safety responsibilities. Management or the employer, he must ensure all the machinery is properly guarded. Supervisor, what are his responsibilities in regards to machine safety? He must train the employees on specific guard rules in their areas. He must ensure all the machinery guards remains intact, in place and in safe condition, and is in good working condition. And he must immediately correct machine guard deficiencies. What are the employee responsibility in regards to machine safety? Do not remove the guards unless machine is locked and tagged out. Any deficiency or any defects, any faults that you identify, immediately report to the supervisor. Do not operate equipment unless guards are in place. And do not operate the equipment if you are under the influence of drugs and alcohol. That's an unsafe practice. So these are the responsibilities of the employees. The training must be provided on the following to all the workers involved in machine operation and also for the maintenance worker. What are the hazards associated with the particular machine? What are the safeguard systems that provides protection? And what are the hazards for which are intended? Why to use a safeguard? When safeguards can be removed and by whom? What to do if a safeguard is damaged, missing, or unable to provide adequate protection? So a training must include all these topics to the people who are concerned, people who are involved in the machine operation. Summary: machine guarding, safe machinery related injuries such as from crushing, from abrasion, from puncturing, from shearing, from entanglement, etc. The point of operation and nip points are the two areas where the employer need to focus on and the supervisor need to focus on, and that must be guarded to ensure it is safe for the operation of the machinery and also for the employees. A good rule to remember is that any machine part or function or process which may cause injury, it must be safeguarded. That's the end of this topic.